Hello, pre-calculus students, and this is a discussion on a problem regarding distance and velocity, in particular as it relates to falling or projectile objects. And so this problem gives us this information that a rock is thrown straight up from level ground. The velocity of the rock at any time t in seconds is v of t equals 48 minus 32 t feet per second. And it's asking us to do a few things here. First, graph the velocity function. B, at what time does the rock reach its maximum height? And C, how far has the rock traveled at its maximum height? Okay, so let's just start with part A here. And the key phrase is this is that it's a velocity function. Okay, v of t is a velocity function. It is not position. It is not height. The function that we're given here tells you how fast the rock is moving at any particular time. So let's start by graphing that. So let me draw my xy plane here. And I'll just rewrite the function. V of t equals 48 minus 32t. Okay. And I can graph this using a TI-83, but I think it can be done just as well here with some basic geometry or algebra rather. So I know that the y-intercept is going to be 48. And I can find the x-intercept by setting the function equal to 0. It's 48 minus 32t. Add 32t to both sides. Divide by 32. And I get that t is going to be equal to 1.5 seconds. So let me mark here. Let's see, 1, this is 2, and this is 1.5 seconds. This is the y-intercept, and this is, of course, a line. This is the equation of a line. Let me draw this better here using a ruler. And so there you have it. And again, this function, this line right here, represents how fast the ball is moving. So just to illustrate something, and this is in seconds, and this is the velocity here along the y-axis, so this is in feet per second. And let's say at 1 second, this is the point on the curve. This is v of 1, which is 48 minus 32 times 1, which comes out to 16. Okay? Now this 16 here, it does not tell you the height. It tells you how high above the ground, or it tells you how fast the rock is moving. So it does not tell you the height, the position. This 16 here means that it's moving at 16 feet per second. Okay? So looking at this number alone, we really don't know where the rock is located. We just know that it's moving at 16 feet per second. Okay, so this is not part of the problem, but it's just, I'm writing it there just to help you illustrate that this is not position, this is velocity, or how fast the rock is moving. So let's see what else we're asked to do here. Part B, at what time does the rock reach its maximum height? Okay. And notice here the question is, when does it reach its maximum height? But looking at the function here, again, this is a velocity function. It tells us nothing about the height. We don't really know how high the rock is at any particular point here on this graph. We only know how fast it's moving. So we have to think a little bit more here regarding what does it mean for the velocity of an object when it's thrown up in the air and it reaches a maximum height. In other words, I'm going to rephrase that question just a little bit and say, how fast is the rock moving when it reaches its max height? Okay, and this is really a physics question about all projectiles, not just this rock. So let's take a look here. I have this cube here, which is going to represent my rock. And if I toss it up in the air, it reaches maximum height, it starts to come down. So the question here is, how fast is it moving when it reaches that max height? So again, if I toss it up, it's going to move up. And you can see that, you know, for any object, before it starts falling, or when it reaches its max height, it stops going up and it falls down. So in other words, when it reaches its max height, the velocity is 0. Okay? So that's important. I'll say that one more time. When any projectile object reaches its max height, the velocity is. So the answer to our question here is that when any object is flying up and it reaches its max height, at that instant, the velocity is equal to 0. Now this doesn't quite answer this question here because it's asking for at what time does the rock reach its maximum height. It doesn't ask us how fast it's moving. But now we can look at our graph here and see, well, where on this graph does the velocity reach 0? And that, of course, is here at the x-intercept. At this point, v equals 0. And I already solved for it over here by finding the x-intercept. Time is equal to 1.5. So the answer to the question here is the velocity is at 0, and the time in our particular example is 1.5 seconds after when it was launched. And let's look at the last part here. How far has the rock traveled at its maximum height? Okay, so this is somewhat of a tough question because it's asking us how far has it traveled. And notice here, as we look at this graph, again, this is a graph of velocity. It does not tell us anything about position. So we have to deduce, or we have to solve everything using only the velocity as our given. Okay? So if we think back a little bit, the way that we find distance, so the word far here represents distance. If we wanted to find distance, then we would have to find the area under the velocity curve. Okay, so we're going to find area under v of t, under the velocity function. And so that is finding the area of this shape right here. Now, if this was a curve like a parabola or some other polynomial, we might have to use rectangular approximation methods, LRAM and RRAM. But this is nice in the sense that we're given a triangle, so we should certainly be able to find the area of this triangle. So part C, let's see, let me use a different color here. So for part C, zoom out so you can see a little bit better. Okay. We're going to find the area of that triangle. Okay, this area right here under the curve. And the area of a triangle is 1/2 the base times the height. Our base in this case is 1.5 from here to here is 1.5, and our height is 48. So it's 1/2 times 1.5 times 48. This is 0.75 times 48, or 3/4 of 48. You could of course type this into a calculator, but I like to do these things by hand, which is 36 feet. Okay. So in other words, if I have a rock here, it goes up, reaches its maximum height, this is the ground, it's traveled 36 feet before it actually comes back down. Okay, so this is the function that tells us how fast it's moving at any particular point, and by finding the area under the curve, we can find how far the graph has the rock here has traveled.